Do you want me to read it to you, or can you read it?
You're either reading it.
All right, I'll just read it to you, whatever. By this point, it should be apparent that finding the limits of Riemann sums is not just an intellectual exercise, it is a natural way to calculate mathematical or physical quantities that appear to be irregular when viewed as a whole, but which can be fragmented into regular pieces. We calculate values for the regular pieces using known formulas, then sum them to find a value for the irregular whole. This approach to problem solving was around for thousands of years before calculus came along, but it was tedious work, and the more accurate you wanted to be, the more tedious it became. With calculus, it became possible to get exact answers for these problems with almost no effort. I have got that part right, no effort.
I said almost no effort.
Because in the limit, these sums become definite intervals, and definite intervals could be evaluated with antiderivatives. With calculus, the challenge became one of fitting the integrable function to the situation at hand, and then finding the antiderivative for it. Today, we can finesse the anti-differentiation step, occasionally an insurmountable hurdle for our predecessors, with programs like NIT, or ARGIS, right? But the modeling step is no less crucial. Ironically, it is the modeling step that is thousands of years old. Before either calculus or technology can be of assistance, we must still break down the irregular whole into regular parts and set up a function to be integrated. We have already seen how the process works with area, volume, and average value, for example. Now we will focus more closely on the underlying modeling step, how to set up the function to be integrated.
I used to read examples whenever I got confused, and then they didn't help either.
Yeah, because like the examples are like, oh, here's one thing, and then like, like the problems are just like far off in left field in the opposite direction of the example.
Yeah, but
This chapter, I feel like, finally answers the question of where do you use calculus. In this chapter, we're going to learn how to take the area and the volume of irregular shapes. Shapes that in the past you could just approximate, but now we can take the function, and we're going to take like the idea of a function and rotating it around the axis to make a three-dimensional figure and finding the volume of it, and it's very exciting stuff. Also, I feel like it's good that this is our last chapter, because I feel like every single section in this chapter is stuff that shows up on the AP exam. So I've already cut out some stuff from this chapter that's not on the AP exam in hopes that we can squeeze this test in, but I don't know, kids. It's going to be a tight. I think it's going to be gross, but they put a pizza up there and they're going to eat it later, but I think they should put it in a refrigerator.
no, I think it'll be a fridge. It'll be totally.
Maddie says you can leave pizza out for 3 days and eat it, so.
Yeah. It's not like it's real food. You can leave pizza out forever.
Hey, I made that pizza by hand. It's definitely real.
It's not real food. How is that gross? Okay, so at my house, if you see pizza left out like over the weekend, you're still gonna eat it.
Yeah.
I'm just
And
saying.
plus, whenever
You
I bring pizza
scavenge
in my
for your
lunch,
food at my
I
house.
get it out and leave it in my lunchbox all day with no ice or nothing.
Yeah, that's what she did yesterday. She was having pizza.
Oh yeah, that was a big piece of pizza.
Okay, so this chapter, this first section, I feel like isn't so bad to do today because we've done this before. It's maybe just kind of writing it a different way. But it says given velocity, which is the derivative of the position function, yes? So position function is s, we say velocity is ds over dt. We can talk about a particle moving left, right, or being stopped. Because if it's moving left, what do we know about its velocity? It's negative, so we could say ds over dt is less than 0. I know it's show eventually.
I just love how you just like now you just like keep on writing. You used to take it more than you just keep writing.
And if it's moving right, what do we know about the velocity? It's positive, so we could say ds over dt is greater than 0. And if it's stopped, what do we know about the velocity? It's equal to 0. So they're going to use words like moving left, moving right, and stopped, but you have to just think about that means like the velocity is less than 0, greater than 0, or stopped. That's not something, right? And all this writing I saved you.
Wow, thanks. We could do this tomorrow, and then we could report.
Yeah, what are we gonna do tomorrow?
7 1 day 2. I'll update the board so you don't feel so wrong.
We're going to celebrate. It's Friday.
So if v of t is the velocity in meters per second of a particle moving along the x-axis, use analytic methods, that means not your graphing calculator, to A, determine when the particle is moving to the right, moving to the left, and stopped. I think it's easiest to start when it's stopped, right? Or moving left. What do you want to do? Determine when the particle is moving to the right, moving to the left, and stopped.
Yeah, when it's equal to 0, you can just equal to 0.
Yeah, when it's stopped, it's equal to 0. So we could just solve this equal to 0, or I guess I could just do this. 0 equals 49 minus 9.8t.
It's Friday.
I got 5.
I got 5. I actually did it on my
divided by 9.8 is exactly.
It's exactly 5.
That's what I did once.
I was like literally gonna question what kind of number was gonna come out of that.
So we could also set the derivative less than 0 and greater than 0, but we should be able to use calculus to say if, this is kind of good review from last semester, if the velocity is 0 at 5, can we think about looking to the left and to the right of 5 and see what's happening, whether it's positive or negative? It's kind of like the first derivative test. Remember doing that? Yeah, but we're only going from 0 to 10, so I guess we should say it's starting at 0 and ending at 10. So we really got to pick a number between 0 and 5 and a number between 5 and 10, right? And where are we going to plug that into? Subvelocity. It's the only one we got, right? So if you plug 1 in there, is that going to be a positive number or a negative number? 49 minus 9.8, positive number. Which means it's increasing, but instead of talking about increasing, we're going to say that means it's moving to the right, right?
We're going to remember all the increases.
That's why after spring break, we're going to do some hardcore review.
Really sounds like you're like,
Is this our last chapter?
That's it. That's why I'd really love to get it in before spring break, but yep. Calc 2 stuff.
For review.
Nope.
Is that BC?
That's what she said.
I was okay.
The review comes from me. If you plug in a number bigger than 5, like if you plug in 6, I think you should get a negative number. Because 5 times 9.8 is 49. Make sure you write out your answer, right? Like this is like our work, but when is it moving to the right, moving to the left, and stopped? I could say it's stopped at t equals 5 seconds. It's moving to the right. It's not going on forever, right? We are stuck between 0 and 10 seconds, so it's moving from the right from 0 to 5. And again, we talked about this last semester, like do you do a bracket or a parenthesis? I say, I don't know. I say parenthesis because at 0 it's well, I don't know. At 0 it's positive though.
It doesn't matter. It's still
I think I think I would put a bracket around the 0, but just so you know, on the AP test, either is acceptable. Okay.
always on everything.
Not just telling us that.
On the free response, if they're talking about intervals of increasing and decreasing, bracket or parentheses are both accepted. On multiple choice, there will never be one choice that's like bracket 0 to 5 and another choice that's parentheses 0 to 5. Like either all the choices will have brackets or all the choices will have parentheses. Does that make sense? So I like to put a bracket around 0 because at 0 is my velocity positive. So I feel like it is. But at 5 is my velocity positive? No. So that's why I would put bracket 0 to 5 parentheses, and then it's moving left from 5 to 10, and it is still negative at 10, so I think I would put a bracket around 10 also. But again, you don't have to. Put parentheses on everything if you want. You good with that? So there's more stuff here. Part B says, what is the position at t equals 10 if s of 0 equals 3? This is kind of like some stuff that we just did on the last test. If they want to know the position and I have the velocity, what can I do to find the position function? take the integral. And why do they give me this point over here? So you can solve for c, right? So same thing we've been doing, it's just kind of maybe looking at it a different way. I need to have more room here. I gotta go back to this. And so I kind of wrote this a different way. Like when they ask you what is the position, they're asking you like how far from 0 to 10 has the particle moved. That would be the integral. The integral from 0 to 10 of the velocity function would tell you the distance that it traveled from 0 to 10 seconds. I wrote all the stuff underneath there, which really makes no sense when it's just there instead of me kind of like showing you a step at a time. Plus the initial position, so plus, okay, humor me for a second. Instead of solving for C, which we could still do, you're still going to get the right answer, but if from 0 to 10 gives me how far it traveled, and I just plug in where it started, is that going to give me the new position of it? So this is what we call the displacement. The displacement, if you've ever taken physics, displacement is how far has it moved from points from this time to this time. So how far has it traveled from 0 to 10 seconds would be the velocity. But I don't want to just know how far did it move from 0 to 10 seconds. I want to know where is it after 10 seconds, which means I have to take into consideration where it started, right? So this is kind of like there's two ways to do this problem. The one way to do it is integrate it, add c, plug the point in, solve for c, and then figure out where it is. I feel like that's a lot of work. But what if I just took how far it moved from 0 to 10 seconds? Oh my gosh.
Like, you never even finish the circle at top.
You're trying to write 10.
0 to 10 seconds. And this is where it started. So if you just take this integral from 0 to 10 and you add the initial value, then you'll get the new position. That pizza problem from the test yesterday, you can do like this. You don't have to. You can solve for C. That's how I did it, because that's how we've done it before. But this is what we call initial value problems. So all this stuff, I don't even know why I wrote all this, but basically just to try to remind you that to find the displacement, you can just, like, you could talk about rate times time, that's Riemann sum, that leaves definite integral, but it means like nothing. This is the part that's super important, I think. The super great part is if you're allowed to use a graphing calculator, you could do this on your graphing calculator, right? Like you could take the integral from 0 to 10 of your velocity function and then add 3 to that, and that's your answer to how it traveled. Do you believe me on that, or? This is just me talking. Just kind of ignore all this garbage. The question is just, what is the position? Okay? And so maybe you were already integrating this because you were so excited to integrate the integral from 0 to 10 of 49 minus 9.8t. And then I'm going to put plus 3 out here. We're not integrating the 3, right? Like that's just kind of like adding in your initial value. And this would, I feel like if this was on an AP test, it would be a calculator problem, which means you wouldn't have to integrate by hand. But I feel like right now, I want you integrating by hand, but you obviously use your calculator to calculate like the arithmetic part. But don't just be typing this in your calculator right now. Right, so this would be 49t minus 9.8t squared all over 2 from 0 to 10. And then add 3 to that. How great is it that it's from 0 to 10? Because it's my favorite one, because you plug 0 in there, it's all 0. So you get 49 times 10 minus 9.8 times 10 squared, which is 100, all divided by 2, minus 0. And then add 3 to that. And what do you get as your answer? No one's doing it.
I did it.
Yeah, guess what happens? The integral ends up being 0. which means from 0 to 10 seconds, whatever it moved, it like undid itself. Does that make sense? Right, like it's kind of like, think about what we know about integrals. Whatever was above the x-axis, there must have been the same thing below the x-axis, and they canceled each other out.
Whenever you're doing a plus c, is it always after you take it from like 0 to 10?
Yes, like if you're adding, yes, and I think I have this written out better in a minute, or maybe it's tomorrow, of kind of typing out, like writing out the rule. Like if you're trying to find total distance, you're always going to take the integral and then add where you're starting. As opposed to if you just want to know, like sometimes they'll just say, how far did it travel from 0 to 10 seconds? The answer to that would just be 0. Like it didn't travel at all, like it canceled each other out. Does that make sense? See if this will work yet. Like this cancels each other out. Then you add 3, which means after 10 seconds, it ended where it started, is basically what that's telling you. And we can look at the graph and see that. As opposed to, look at this question. Part B was find the position after 10 seconds, right? That's what part B said? Or where is it after at 10 seconds? Part C says find the total distance. And too bad I printed these out for you that I can't ask you what is it to find total distance because it's right there on the thing for you. But remember when you want total distance, you want to know like the whole thing, which means you take the absolute value of the integral. Remember doing that? So, keyword here is when you see the word total, then you do absolute value. The awesome part is again with a calculator, you can do that on your calculator and it'll give you the answer as well. What's wrong? About the zeros? If we are doing this without a calculator, that's where you have to break it up at the zeros because you want to take like the integral of what's below the x-axis and what's above the x-axis. The good thing is part A, we already found the zeros. Where did the velocity equal 0? At 5 seconds, which means we could break this up as 0 to 5 seconds of the velocity function, absolute value, plus the integral from 5 to 10 seconds of the velocity function. And if I just want to know the total distance traveled from 0 to 10 seconds, does where it start have anything to do with the total distance traveled from 0 to 10 seconds? Does that 3 that we used in the last problem have anything to do with this problem? No. I don't care where it started. I just want to know how far did it move in those 10 seconds. Does that make sense? Here's what's also super great. We already just find the integral of this, which means don't redo all this work every time. Like we already know that it's 49t minus 9.8t squared over 2, but you can actually take that over 2. I just did it on the calculator, but yeah, it's just 4.9. From 0 to 5, absolute value, plus the absolute value of 49t minus 4.9t squared from 5 to 10. And again, using from part A, we already know from 0 to 5 seconds it was positive, which means we should get a positive number there when we need absolute value. And from 5 to 10 seconds, we already know it was negative, which means that's the part that was below. We also should be able to say, from the last problem, knowing that they canceled each other out, what should we know about these two numbers when we get them? They should be equal. One should be positive, one should be negative. So it's like, so we can kind of put that stuff together as you're doing it. Like I'm okay with you just working it out. But they should be the same number except for one's positive and one's negative. I'll write my work up here too, just because I have it on my paper already. I plugged 5 in there. How is 49 times 5 a decimal? Oh wait, it's not. I did all this together and just wrote one number down. I was so confused for a second because this is what I have down as my absolute value. So I must have just plugged 5 in for all of that. And again, you should be doing this so that we can check that we're getting the same thing. But those were my numbers that I got on the other one. Let's do this one. Like I plugged in 10, so I got 490 minus 490. Is that right? Yeah. And then I plugged in 5, and I got minus 245, and then minus negative, then plus. That's just me showing the word. You probably just did all your calculating. Yeah. That's okay. This ended up being negative 122.5, but when you take the absolute value, you should get 245. That's the total distance it moved. Doesn't mean that, how far did it travel or what's the new position, like on part B. It ended where it started. It moved a lot, but it ended back where it started because the positive and the negative cancel each other out. Again, much faster if you were using your graphic calculator, which we will do some with our graphic calculators as well. So I think the only thing I have left on here is just trying to kind of put this all together, which again takes away some of the putting it all together, but it's all just for you on the paper. But I'm going to cover it up anyway, just to try to a step at a time. When you integrate the velocity function, you're finding displacement. And again, they use the word displacement sometimes in this book, and I feel like people don't always know what that means. But displacement is just what happened during that time period. It's the net area between the velocity curve and the time axis. Or, what did I say there? Or it's, you could say, how far did it travel from the interval A to B? If they ever ask you, how far did it travel? That's displacement. As opposed to, if they ask you for the new position or the ending position, like on part B, what is the position after 10 seconds? We're going to write that here so you can kind of match it up. What is position after 10 seconds? That's where you do the integral, but you have to add in where it started, because if it didn't start at 0, then you have to add that in. Like if it started at 5 and then it moved to 10, then the new position would be 15. So that's where you have to add in the original. Okay? And then when they ask you for total distance, you just have to remember to take the absolute value. And there was a question, I don't know if it was I think it was the year before, because last year I was on maternity leave and I don't even think I ever worked out with their problems. I was that also. But the year before on the free response, one part of one of the questions, like part B, was find the total distance traveled. That was the only question, and it was with the calculator, which means all you had to know was do on your calculator absolute value of the function given, and you got the answer. And that's it. And so it was just knowing total distance means absolute value. If you didn't have a calculator, then you have to break it up by the zeros. Okay? That's it, I think. That's not bad today. This is your homework. We can kind of look at number 1 together, but I thought maybe you're going to freak out because number 1 is trig and you're going to cry because you're going to be like, trig is awful. But you do it the same way. You just have to think about where cosine equals 0, right? So I'm not gonna do this whole thing because I want to talk about the test. But number 1 and 4 and 6, I think, have the same directions as the one problem we did today. Like they're part A, B, and C. Part A is find where is it moving to the left, moving to the right, and stopped. Find the new position. Find the total distance traveled. But I just want to do part A to try to help you with trig and remind you that trig's not the worst thing in the world. So you can just do this on this paper if you want, or you can get your own paper out and label it however you do it. And then copy it down later. I know. I'm taping this for her, so hopefully she'll watch it. That's right. She got to hear me reading the book to you, too. So, how do you find where something stopped? Set the velocity equal to 0. Does that 5 have anything to do with where cosine equals 0? No, because you can just divide. So this is where you have to know some trig. between 0 and 2 pi, where does cosine equal 0? Which means if you want to go ahead and set your intervals up, you can. Or if you just want to draw the line and then do your intervals later. Again, we're not going to infinity and negative infinity here. We're only going from 0 to 2 pi, which means we have to look between 0 and pi halves. Oh my gosh, projector overheated. It's just going to shut down right now.
I just have to turn it on.
This happens in class every day. It's never happened before. But it happens to her
It
every day.
happened to Mr. Rhodes, like, he said he had to, like, his projector would not turn on.
Are you opening your window? The projector?
Yes.
Where's the projector? You can see the key going.
0 to pi halves to pi, no, pi halves to 3 pi halves, 3 pi halves to 2 pi, yes?
I think you have it.
3 5/4.
If you know what the graph of cosine looks like, you should be able to tell me whether it's positive or negative by just thinking about the graph itself, but we don't have to. We can just plug values in there. Sean says pi force. Like if you plug pi force into cosine, is pi force, cosine of pi force positive or negative? So here's zeros. We found our zeros to be positive, which means that it has to be going to the right between 0 and pi halves. If you take any angle between pi halves and 3 pi halves, think about that quadrant 2 and quadrant 3 of the circle, right? What do you know about cosine in quadrant 2 and quadrant 3? And then from 3 pi halves to 2 pi, that's quadrant 4. What do we know about cosine? People kind of freak out about trig, but I like trig because I don't have to actually plug numbers in because I just think about where it's positive or negative. So we can say for part A on number 1, it is stopped at pi equals pi halves and at 3 pi halves seconds. It's moving to the right where it's positive. And again, it's okay if I go through this, but I'm going to say bracket 0 to pi halves and from 3 pi halves to 2 pi. And it's moving left from pi halves to 3 pi halves. They're also going to ask you about distance traveled, which means you're going to have to integrate cosine. You can integrate cosine. You can use the bounds, right? You can do this. So we'll see what questions we have tomorrow and then go from there. But at least get that written down, and then I'm going to touch test back. But I can't use the.
Your chapter doesn't go. None of us.
I know, right?
So I put the percentage that you got on the test with the number that you got on the test. The bottom number in pencil is the grade that wins the grade book with my little formula that I use. There, you can still retake this. The retake is just a regular test, lots of deep substitution, just integrating. But I do want to look at a couple of these, and then you're going to just work on test corrections, and then just see me for extra help on test corrections if you need it. But I want to look at the pizza problem. You know, the recording just stops abruptly for Rachel.
Did it even save it, or?
Oh, I wonder if it's still recording because all that happened is the projector stopped, right?